Alright guys, so this is the one that we were working on yesterday, the differential equation that we were working on. And if you remember, we decided we were going to treat the dz and the dt like they were separate, okay, and could be moved around from one side to the other. So if we multiply both sides of the equation by dt, okay, we start to get what sort of almost looks like the end part of an integral. But I want to keep all the same letter together. So I want to keep the z's with the dz and the t's with the dt. Well, we don't have any t's, but I do have a z that I can divide, which gives me 1 over z dz equals r dt. And this looks a lot like the second half of an integral. So I'm going to go ahead and integrate both sides, okay? Since I started with what we called a differential equation, which remember just means an equation that involves a derivative, to undo the derivative, I'm going to have to take an integral. So that kind of makes sense. The integral of 1 over z is natural log of z, and the antiderivative of r, remember r is a constant with respect to time, is rt, and since this is an indefinite integral, I need a plus c. Now I would actually have a constant on both sides, but if you remember, we talked about this before. We're going to just sort of put the constant on one side and let that take care of any ambiguity that comes from the whole entire problem. So since we want an equation that involves z, okay, z equals, we want to get z by itself. So what I'm going to do is e both sides, which gives me z equals e to the rt plus c. All of that is in the exponent. Okay, which doesn't yet look like, remember we had our zert, doesn't yet quite look like that. So let's see what we can do. We've got e to the rt plus c. If you remember your exponent rules, I can make this e to the rt times, excuse me, e to the c. All right, but e is just a number, c is any number, so I can really call this anything I want. I'm going to choose to call it a capital Z sub 0. And the reason that I'm choosing capital Z sub 0 is if I look at my equation, when I plug in t equals 0, okay, I get z equals z sub 0 e to the 0, which is 1, so I get z sub 0. Okay, which means that that is my initial population. That's how many zombies there are at time t equals 0. Okay, so this differential equation is what gave us our solution curve, right? How we came up with how many zombies there are going to be after how much time. Okay, this is just one differential equation. We can solve lots and lots and lots of differential equations, and in fact there are tons and tons and tons. We are only going to learn how to solve the type that is separable. Separable means that it can be rearranged, okay, so that all of the y's and dy are on one side, x and dx on the other side. Okay, so I'm going to go ahead and work a few more example problems for you. This first one, all three of these are differential equations because they are equations that involve a derivative. This first one, dy dx equals 2x over y. If I multiply both sides by y and and multiply by dx. So let me go slow. I'm going to multiply both sides by y, and then I'm going to multiply both sides by dx. I could have thought about that as cross multiplying right from the beginning, okay? And then I'm going to integrate both sides, all right? So the integral on the left in terms of y, antiderivative of y is 1/2 y squared. Antiderivative of 2x is x squared, and don't forget your constant, okay? We have a plus c. If we can, we should try to get y by itself. Now that's not always possible actually, but in this case it is, so we want to try to get y by itself. So we have y squared equals 2x squared plus c. Now some of you might be saying, Miss Welsh, you forgot your 2. It's really plus 2c, and you are correct. You are absolutely correct. However, remember that c is arbitrary. It can be anything. So c, 2c, 3c, c over 7, it doesn't matter. It can be all the same thing. Okay, c is just an arbitrary constant. So to get y by itself, I'm going to need to take the square root, and please don't forget plus or minus. Okay, so there's what we call our particular solution for that differential equation. Okay, so let's try another one. dy dx equals y squared. So I'm going to multiply the dx onto the other side. This is the separating part. Okay, you're separating the y's and the dy's from the x and the dx. You want to divide both sides by y squared. So I get 1 over y squared dy equals dx. Now, I really could rewrite this if I wanted to as y to the negative 2, which is going to make my life easier when I integrate. Okay, now I'm going to integrate both sides. Antiderivative of y to the negative 2 is negative y to the negative 1. The antiderivative of, oh, it looks like nothing. It's really a 1. The antiderivative of 1 is x. And don't forget your plus c. Okay, now I want to get y by itself. Don't forget. So the first thing I'm going to do is get rid of that negative sign. So I'm going to make this negative x plus c. Again, you might be thinking minus c, and you're right, but remember c's arbitrary, it can be anything. And then to get y, okay, to undo that negative 1, right, I'm going to flip. So I get negative x, 1 over negative x plus c for my particular solution. Okay. Let's do one more, and this one's got trig. Yikes, it looks super scary. Okay, notice I can cross multiply this one. So I would get 3y squared dy equals x plus sine x dx. Okay, you are ready to integrate once you have all the y's and dy's on the left, all the x's and dx's on the right. Okay, so now I can integrate both sides. The antiderivative of 3y squared is y cubed. The antiderivative of x plus sine x, antiderivative, is 1/2 x squared minus cosine x plus c. Okay? To get y by itself, because if we can, we should, we need to take the cubed root of both sides. So y is the cubed root of 1/2 x squared minus cosine x plus c. Okay, I hope that this is enough for you guys to get started on your homework. The homework is not due Monday, so don't panic. If you have any questions at all, feel free to send me an email or a text, or pick up the phone and call me. Okay, I will be around today and of course all weekend to answer if you guys have any questions. Okay, good luck. Have fun today.